idea where that website is. There is a massive communication gap here. Humans navigate the web using easy-to-read words and names, but computers can only connect to each other using numeric IP addresses. Think of an IP address as a phone number for a server. There are billions of these addresses scattered across the globe, making it impossible for humans to memorize the numbers for every site they visit. So the seamless web we experience every single day entirely relies on a massive, invisible directory that translates our human language into machine code in milliseconds. The journey starts right on your computer with the stub resolver. The stub resolver is the built-in DNS client on your machine that acts as your local directory assistant. First, it checks its cache to see if you visited the site recently. If the IP address isn't saved in that recent memory, it has to seek outside help. Your query leaves your home router and travels to a recursive DNS server, like Google's public 8888 server. This server acts as a digital detective, tasked with tracking down the exact IP address you need. That single outgoing packet from your house triggers a highly orchestrated global game of telephone just to find one specific number. If that recursive server doesn't know the answer, it has to go straight to the absolute highest authority on the internet, the root servers. These top-tier servers are operated by 12 heavy-hitting global organizations. We are talking about groups with immense geopolitical weight, including the U.S. Department of Defense. NASA is also on that short list of organizations managing these critical root server groups. But these root servers don't stoop to memorize individual website IP addresses. Instead, they simply delegate the request down to top-level domain or TLD servers, which handle the .com or .net spaces. Even at the highest echelons of global internet infrastructure, the system functions entirely on delegation rather than absolute knowledge. The query hits the TLD server, which acts essentially as middle management. It merely points our digital detective to the specific organization that actually owns the requested website. Finally, we arrive at the authoritative main server. This is the ultimate boss that holds all the technical secrets for that specific domain. Looking at this visual representation of a zone file, we see a master ledger connecting domains to their physical server locations. Specifically, the A record is the exact line that maps the human-readable domain name directly to its numeric IP address. This is the exact moment the recursive server's query locks on to the target IP address. Armed with the location, the IP address packet shoots all the way back down the chain, hits your laptop, and your computer finally loads the web page. In the 40 milliseconds it took you to blink, your computer successfully interrogated a multi-layered global hierarchy to connect you to your destination. As fast and reliable as this engineering marvel is, it has a fatal flaw. By default, DNS relies on UDP port 53, an older communication protocol that was never designed for privacy. Because of this, these global queries travel in plain text, meaning they are completely naked and unencrypted as they move across the network. The privacy consequences are severe. Anyone sniffing the network, from a hacker in a coffee shop to your own internet service provider, can read the outside of these packets to see exactly which websites you are visiting. It also opens the door to DNS spoofing. This is an attack where hackers intercept your naked query and reply with a fake IP address, redirecting you to a malicious server without you ever knowing. The internet's core navigational tool operates on an outdated system of blind trust, leaving every user's browsing habits exposed by default. To fix this massive vulnerability, the industry developed a modern cryptographic solution known as DOE, or DNS over HTTPS. HTTPS is the standard protocol we already use to securely encrypt the actual content of a website, keeping sensitive information like your passwords and credit card numbers completely hidden. DOE takes the plain text DNS query and wraps it inside a secure HTTPS connection. Snooping bad actors can no longer tell the difference between a DNS request and a video stream. All they see is meaningless cryptographic noise. The modern internet is a fascinating paradox. It is built on an ancient, fragile system of plain text directions, yet it remains functional and safe today through the continuous evolution of cryptographic camouflage.